This tape is going to discuss the hypothalamus and limbic system. And if we take the camera down to this little brainstem section here, we can recall the spinal cord and the pons and here the colliculi, and we're going to be down in this hypothalamus area down here. And we're going to talk about temperature regulation and why some of us eat too much and why some of us are skinny and all those kind of things like that. Now, if we pan up back to my face here, you can see this shirt here. And I've got a lot of comments this morning on this shirt. And most of them have been negative, which upsets me. One medical student even went so far as to ask me if I actually picked this shirt out. Well, this happens to be one of my favorite shirts. So I don't know if that relates to hypothalamus and limbic, but it kind of gets my emotions going. So why don't we go to the tape? Well, I want to welcome everybody to the wonderful world of Module 3. This will be a pretty lengthy review that'll go through the highlights of the module. As I told you, there'll be copies of these slides in your mailboxes so that if you don't want to go over this tape or if you want to use those slides, those prints, as we go through, it might help you. We'll start off with Dr. Sievert's material when he talks about the hypothalamus. And I think when we say skinny or fat, hot or cold, I hope most of you have a clue that we're talking about control of eating, control of temperature, control of many of the drives that we exhibit as primates. When we look at the bottom of the brain, Carl sectioned the hypothalamus at 3 levels. One of them was up here rostrally through the commissure, through the optic chiasm right here. We called this level 1 through the hypothalamus. So we then had a level right here through the middle called the tuberal level. And then we had a level back here through the mammillary bodies. So here you can see the hypothalamus, the caudal limits being the mammillary bodies, the rostral limits being the optic chiasm. And again, 3 levels, 1, 2, and 3. When we go to the first level, we go right down here and you see the chiasm, the crossing of the fibers. And we know that there's a nucleus that sits right on top of the chiasm called the suprachiasmatic nucleus. It's a little hard to see here, but I don't want you to confuse suprachiasmatic with what sits out here, supraoptic, and what sits up here, paraventricular. Now, the thing you need to know about suprachiasmatic is that it gets direct input from the retina. So these cells are being informed about whether it's light or dark. So these cells are very important in the circadian rhythms. And we're going to talk a little bit about the suprachiasmatic nucleus later on when we talk about sleep. When we go out here, we have a supraoptic nucleus, which is involved in oxytocin and vasopressin. These cells send their axons down to the posterior pituitary where it's released. And then when we go up here, we have the paraventricular nucleus, which produces CRH and also oxytocin and vasopressin. Of course, the CRH goes down to the anterior pituitary via the portal system. Now when we go to the middle or tuberal zone, remember the fornix divides this region into a medial and a lateral zone. When we go down in this region, I think about the arcuate nucleus, and the only thing I think about there are releasing hormones. When I go medial to the fornix, I think about the ventral medial hypothalamic nucleus, and I just think that if I have a lesion here, a person's going to be very, very fat. And then when I go out here to the lateral hypothalamic area, I think about a person with a lesion here who's going to be very, very skinny. Finally, we go to the most caudal part of the hypothalamus. Here we can see the mammillary bodies. There's a little nucleus up in here called posterior that you can't really see. When I think about the mammillary bodies, I think the main thing you should know is that when you have lesions in the mammillary bodies, you have something called Korsakoff syndrome, and you cannot form new memories, just like in the case of the hippocampus. But in this case, you can't form new memories, plus you have something called conflagulation, where you make up stories. So you should know Korsakoff's mammillary bodies. You should also be able to take the mammillary bodies and go into what we call Papes circuit. If you're in the mammillary bodies, you're going to go up the mammillothalamic tract to the anterior nuclei. Once you're in the anterior nuclei, you're going to go up to the cingulate gyrus up here. Then you're going to jump into the cingulum, Go all the way back, the bundle, the cingulum, that's just the bundle of the cingulate gyrus. You're going to go all the way back down in here to the parahippocampal gyrus. You're going to feed into the hippocampus. Then once you're in the hippocampus, you're going to jump in that beautiful structure called the fornix, and then you're going to dive into the mammillary bodies and start through Papes circuit again. The next section we had was olfaction, limbic, and most of you should understand what interested or not interested means when we start talking about the limbic system. If you don't know what that is, we'll just leave it at that. But this is a really important system for behavior, viscera, emotional things like that. But first of all, we've got to talk a little bit about the olfactory system. And I think where students make the biggest mistake is that they don't realize how tiny this olfactory nerve is right here. So here are the bipolar receptor cells. So these little cell bodies here are in the olfactory mucosa. And there's these little fine fibers that go up through the cribriform plate of the ethmoid right here. And then they synapse in the olfactory bulb, which is pretty large. Then the nerve ends right here, and then you have the tract. That goes back to olfactory cortex. So don't confuse and remember that that nerve is very small, fine fibers. The nerve synapses in the bulb, and then you have mitral cells in the bulb that give rise to the tract that's pretty big and goes back to what I would call olfactory cortex. Now, here's the bulb, so we don't see the nerve anymore. Here's the tract coming back, and then you can see that the olfactory cortex is on the medial aspect of the temporal lobe. Okay, all this area in here. Now we're looking down on the underneath structure of the temporal lobe here, and this would be called the parahippocampal gyrus. So it's all this cortex lying on top here, actually underneath, but it's laying on the ventral surface of the parahippocampal gyrus. Remember, you got this little bump here called the uncus, and we talk about that when it herniates, but that's olfactory cortex here. And then you can come into this region right here at the end of the olfactory tract, which is called the anterior perforated substance. So all these areas here are olfactory cortex. Now remember, you've gone from the nerve into the bulb, into the tract, back to the cortex. Now, interestingly, you can jump in to the thalamus, to the medial dorsal thalamus. From the medial dorsal thalamus, you can go to the insular cortex, and you can also go to this orbital, infraorbital cortex right here. Now, the limbic system in the limbic lobe can sometimes be confusing to medical students. So why don't we take the lobe first, okay? This means edge, limbic lobe. Now, when I think about the lobe, it's just think about the medial aspect of the hemisphere, and the biggest thing you're going to see here is the cingulate gyrus right here. Here's your corpus callosum. And, okay, so you have your cingulate gyrus, and don't forget the big bundle that lies ventral to the cingulate gyrus is called the cingulum. You come back here medially, you get the parahippocampal gyrus. There's your uncus. There's also a little area here called the septal area that we haven't talked about. But here's your lobe. Then all I do is include Papes circuit in here to get the system. So to get the system, I'm going to know all the lobe, and I'm going to jump into the system here. I know what's deep to here is the hippocampus. I know the fornix comes out of the hippocampus, dives down into the mammillary bodies. Mammillary bodies project to the anterior nuclei via the MTT. Anterior nuclei go to cingulate cortex, you jump into the cingulum, and you're back here. So you start with the limbic lobe, which you can see on the medial aspect of the hemisphere. Then you add all those pathways that you know are associated with all this, and you get the limbic system.